In this video, we'll be discussing the polar form of complex numbers. Consider the complex number x plus yi that corresponds to a vector OP with direction angle theta and magnitude r. And I have that illustrated here on the left. It's a diagram we've seen many times in trigonometry. We've dropped a perpendicular, created a right triangle, labeled the sides of that right triangle x and y. So all the relationships that we've discussed throughout trigonometry are still true. SOHCAHTOA applies, so cosine is equal to x over r, and we've manipulated that to x equals r times cosine of theta. We know that sine is equal to y over r, and we've manipulated that, saying that y is equal to r times sine of theta. Pythagorean theorem tells us r is equal to the square root of x squared plus y squared, and tangent of theta is equal to y over x, where x isn't 0 per SOHCAHTOA as well. Well, if we take, this trig portion here, r cosine theta, r sine theta, and substitute it in for x and y in our x plus yi, it brings us to r cosine of theta plus r sine of theta I. Notice that we have a common factor of r that can be factored out, bringing us to r times the quantity cosine of theta plus I sine of theta. This is our polar form of a complex number. Sometimes it's called polar form, sometimes it's called trigonometric form. Now, the expression cosine of theta plus I sine of theta is a lot to write. So mathematicians, we like to abbreviate. Sometimes you'll see it abbreviated CIS of theta. Thus, r times the quantity cosine of theta plus I sine of theta is written r times CIS of theta. The r is the absolute value or modulus of x plus yi, and theta is the argument of x plus yi. In this section, we choose the value of theta to be in between 0 and 360 degrees. However, any angle coterminal with theta could also serve as the argument, but we'll keep the angle small, keep it 1 revolution. Let's write each complex number in rectangular form. This is not hard. All we have to do is find our exact trig values and then clean it up. In our first example, we have 6 times the quantity cosine of 30 degrees plus I sine of 30 degrees. I'd be inclined to distribute the 6 right away. Now we'll find the exact trig values off of our unit circle. Cosine of 30 degrees, that's square root of 3 over 2. And sine of 30 degrees, that's 1/2. Then we'll just, clean this up. 6 times square root of 3 over 2. That's going to be 3 square root of 3. 6i times 1/2 plus 3i. Our next one is written in our abbreviated form. So I'd just start by writing it in the more expanded form. This is the square root of 3 times the quantity cosine of 315 degrees plus I sine of 315 degrees. I'm going to distribute the square root of 3. And now we'll find our exact trig values off our unit circle. Cosine of 315 degrees is square root of 2 over 2. I don't really love this I hanging out here in the middle. Careful that you don't put it under the radical. Sine of 315 degrees is negative square root of 2 over 2. And now we just need to clean this up, multiplying straight across. We'll get the square root of 6 over 2. Now we have a positive times a negative, so this will be minus I square root of 6 over 2.